This is part 2 of the video notes for Objective 3C, Writing Polynomial Equations. In this portion of the notes, we're going to focus on equations from a graph. And so we're going to start with a pretty vague sketch of a polynomial function where none of the tick marks are labeled, and the graph somewhat looks like this, with a 1, a -1, and a -3. In this case, you just need to use the picture to identify the zeros, their multiplicity, and the overall degree of the function. For example, I can tell that this is an x to the 1, 2, 3, 4th power, because there are 4 directions. That means when I'm done writing the equation, I should have a highest exponent of 4. Starting here, I have the 0, -3, which gives me the factor x plus 3. And because the graph bounces off of this 0, I know that it's squared. Here, I have a 0 of -1, which gives me a factor of x plus 1. And here, I have a 0 of +1, which gives me a factor of x minus 1. I don't have enough information in this graph to figure out the front coefficient if there is one. Normally, I'd be labeled an extra point such as the y-axis, which would allow me to solve for a. Since I'm not given that, I'm going to assume a front coefficient of a equals 1, meaning I don't have to put anything out front. From here, I just need to use the same skills from part 1 of the video notes, where I'm writing equations algebraically just by multiplying out the factors. And I want to do these in pairs. So I want to multiply x plus 3 times x plus 3 together. I want to multiply x plus 1 and x minus 1 together. And then I'm going to multiply the results of those products together. Here we've got x squared plus 3x plus 3x plus 9. And here we have x squared minus 1x plus 1x minus 1. Simplify each polynomial, leaves you with x squared plus 6x plus 9 and x squared minus 1. More multiplication. I need to do x squared times x squared times -1, 6x times x squared, 6x times -1, 9 times x squared, and 9 times -1. From here, I want to combine like terms and be super careful that your exponents actually match. For example, -1x should be added to the 9x squared, and actually nothing else. Write your answer in standard form: x to the 4th plus 6x cubed plus 8x squared minus 6x minus 9. And that is my final answer for example 5. The next example in this portion of the video notes is a graph with a little bit more detail. In this graph, because we have specific point values, we're going to need to consider a front coefficient a and how we're going to find that front coefficient a exactly. So we have a point here at 0, 0, a point at 2, 0, a point at 1, -4, a point at 4, 8, and a point at 5, 0. This function is odd. It's also odd negative, which tells me that the leading coefficient is negative, and that the highest exponent should be 1, 2, 3. So let's start by identifying the zeros and writing them as factors. My first 0 is 0, and that leaves me with an x out in front. My next 0 is +2, with a multiplicity of 1, and my last 0 is +5, also with a multiplicity of 1. Put a front coefficient of a and set it equal to f of x. We're going to plug in one of the given ordered pairs that's not a 0. So we need to plug in 1, -4, or 4, 8. I'm going to pick 4, 8 because it doesn't include any negatives. I also have to erase the graph at this point so that I have room to plug this in and solve. From here, 8 is the output, and we'll say 8 equals. 4 is the input, and we're going to plug it in for each of the x values. This can be simplified by your calculator all at once, or you can do it in your head. We have 4 times -2 times -1, which is 8. So even though we had to solve for a, it turns out that a is just 1. And we don't really have a front coefficient. The last step is to multiply everything together. And I'm going to start with the two binomials. And then I'm just going to multiply the extra coefficient of x at the same time as I simplify the equation. So my final answer is x cubed plus 7x squared plus 10x. And this concludes part 2 of the video notes for Goal 3C, Writing Polynomial Equations.